morning friends, and in this video we are going to solve some more questions based on the method of substitution. And then method of substitution is a very powerful tool in integration because all the given questions will not be fitting directly into the formulas. When to apply the method of substitution, how to apply the method of substitution requires tremendous practice, and at the same time it requires a very good command over the formulas, because if you see the patterns, if you know the formulas, then only you can apply the method of substitution. Now for example, I am taking some question, like here I have one question which goes like x cube dx over x to the power 4 plus 1. Now if you see x to the power 4 plus 1, suddenly it should click into your head that the differentiation of x to the power 4 is 4x cube and differentiation of this constant is 0. Means differentiation of x to the power 4 plus 1 will be 4x cube, and you are getting your desired term. It means you can substitute the x to the power 4 plus 1 as something. So I'll take it as t. So x to the power 4 plus 1 as t, and this will become 4x cube dx equals dt. And then this question x cube dx will become dt over 4 and this upon t. So 1 by 4 outside, integration of dt over t, that is 1 by 4 log mod t plus c, and this is 1 by 4 log mod x to the power 4 plus 1 plus c. So this kind of command, but when you see the term, suddenly the formula should click into your head. Now I'll take another example to prove my point. Now I have another example which goes like this: 1 over under root x 1 plus root x dx. So again, what should be the proper substitution? Should I take root x as something, or should I take the 1 plus root x over something? Should I rationalize and then after I need to take some term as constant or substitute? But the idea goes, if you are very good in formulas, then you know that differentiation of root x is 1 over 2 root x. So if you take the whole thing like 1 plus root x as t, 1 plus root x as t, you find 1 over 2 root x dx equals dt. So this 1 over root x, so 1 over root x dx equal to 2 dt. Now this question can be written as 2 dt. So at the place of this dx over 1 by root x dx, you can write 2 dt, and then down you have just t. So this you can take it as 2 dt over t. This is 2 log mod t plus c, and this is 2 log mod under root x plus 1 plus c. So this is how this substitution can be achieved. And now I'll take another example to explain you in a better way. Now I have another example which goes like 2x plus 4 and then square root of x square plus 4x plus 5 dx. Now you don't need to be panicked by looking at the expression, because this is a linear term and this is a quadratic term, and that is also inside this third. But if you see properly, then we see differentiation of x square is 2x, differentiation of 4x is 4, and differentiation of this constant 5 is 0. Means differentiation of x square plus 4x plus 5 is this very much. So I can take the whole thing x square plus 4x plus 5 as t, then I get 2x plus 4 dx equals dt. Then my question becomes, this and dx together can be written as dt, and this part under root t. So 2x plus 4 dx, 2x plus 4 dx is dt. So this is this and this together is dt, and this is your under root t. Now this will become integration of t to the power half dt. That is integration of, sorry, now I need to integrate. That is t to the power 3 by 2, 1 by 2 plus 1 upon 3 by 2 plus c. This you can write as 2 by 3, and at the place of t you write your term back. So that is x square plus 4x plus 5 whole to the power 3 by 2 plus c. And this is your answer for this question. Now I take some more questions. Now I take one more question which looks like this. 1 plus root x whole to the power n upon root x dx. And just in the previous case you saw that 1 plus root x, the differentiation of 1 plus root x is 1 upon root x. It means this is fitting the bill. So you can just assume 1 plus root x as t and 1 over 2 root x dx is dt. So 1 over root x dx is 2 dt. So this question will become t to the power n and 2 dt. So take 2 outside and this is t to the power n dt. So it becomes 2 into t to the power n plus 1 upon n plus 1 plus c, that is 2, and the t is just hold this thing 1 plus root x whole to the power n plus 1 upon n plus 1, and this is c constant of integration. So now this way this question can be solved. So I take another example again. Now I take this simple question. It goes like sec to the power 4 and tan x dx. Now you know that differentiation of tan x is sec square x. So if you just substitute tan x, then you will get sec square x dx as dt. But what will happen to this extra sec square, because tan x differentiation just gives you sec square x and you are having sec to the power 4x. So what I do that, I simply write sec square x tan x dx. Then I substitute 1 sec square x as 1 plus tan square x. This is the relation. Those who understand trigonometry, they know that the sec square x is 1 plus tan square x. So at the place of this you write this one. There it is just tan x dx, and here you write sec square x. Now if you take tan x as t, then you'll get sec square x dx equal to dt. So this sec square x, this and this dx together will become dt, and then you will have this 1 plus t square times t. So now this whole expression becomes integration of t plus t cube dt, and if you integrate them one by one you'll get t square over 2 plus t to the power 4 over 4 plus c. Now replace t by tan x. So this becomes tan square x by 2 plus tan to the power 4x by 4 plus c. So what I'm trying to suggest that if you have the good command over the formulas, then your brain, by using the method of intuition, automatically suggests that what would be the appropriate substitution. Now I take another example, and this goes like this. Tan inverse x over 1 plus x square dx. So the question goes like this: integration of tan inverse x to the power 3 over 1 plus x square dx. Now those who remember the formulas, that the differentiation of tan inverse x is just 1 upon 1 plus x square. So I can write this whole question as integration of tan inverse x whole cube times 1 over 1 plus x square dx. Now if you are able to separate this form into this form, then you can directly see that if you take tan inverse x as substitution, then you'll automatically on differentiation get 1 plus x square. So let's do this. So here I take tan inverse x equal to t, then on differentiation you'll get 1 over 1 plus x square dx equals dt. So now this term will become t cube and dt. Integration of this is t to the power 4 over 4 plus c, and now put the value of t back to the expression. So you get tan inverse x to the power 4 over 4 plus c. This is your answer. Now I'll take few more examples. Let me clear the screen. Now we do not have any formulas to find the integration of sec x dx. Now how can you find the integration of sec x dx? So there is a method of substitution, and before the method of substitution you have to make some adjustments, just like multiplying something up and down. So first what you have to do, that the multiply sec x plus tan x up and down, sec x plus tan x both in the numerator and denominator, sec x plus tan x dx. Then if you just expand the numerator, you get sec square x dx plus sec x tan x upon sec x plus tan x dx. Now if you just pay attention to sec x plus tan x, differentiation of sec x is sec x tan x, and differentiation of tan x is sec square x. Means you can assume this whole 1 plus, you can substitute this sec x plus tan x as t. So I write sec x plus tan x is t, and then I'll get sec x tan x plus sec square x whole dx as dt. So the numerator becomes dt and denominator becomes t, and its integration is log mod t plus c. Now put the value of t back into the expression. So this becomes log sec x plus tan x plus c. So this is your answer. Now one more expression I'll prove, that is called as cosec x, and using the same technique. Now integration of cosec x dx. There is no direct formula. We have to derive the formula for this using the method of substitution. For that you need to write cosec x and cosec x minus cot x up and down, cosec x minus cot x dx. Then there you see, just expand the numerator, you find cosec square x minus cosec x cot x over cosec x minus cot x dx. Then if you assume cosec x minus cot x as t, cosec x minus cot x as t, so differentiation of cosec x is minus cosec x cot x, and the differentiation of cot x is minus cosec square x, but we already have a negative term, so this will become plus cosec square x dx equals dt. Now just take what we need cosec square x minus cosec x cot x. So what you can do, that you just can take order, you can just change it, or you can say even if you just let it remain, but actually it is same thing, because cosec square x minus cosec x cot x dx is dt. So this numerator is already fitting the bill, that is dt. Sorry, here I made a blunder, this is dx. So this is dt over t. So this gives you the log mod t plus c, and this log mod t can be written as log mod cosec x minus cot x plus c. So the integration of cosec x dx is log mod cosec x minus cot x plus c. So this is how this question can be solved. I take few more examples. Now I have another question which has the form like sin x over sin x minus a dx. Now you see that sin x over sin x minus a, if you just expand sin x minus a, then it becomes sin x cos a minus cos x sin a, and that gives you nothing. Denominator is expanding unnecessarily. If the numerator is expanding, then at least we can write in the form of two or more fractions, but here in this case this is not possible otherwise. So what I suggest that you just take this x minus a as something. So I say let x minus a as t, so x is t plus a, so dx equals dt. So you are not finding any relation with the t here, just because it's just plain dx is dt. So if you take x minus a as t, then the dx will become dt. Now at the place of this dx you write dt. Now this x is t plus a, so this becomes sine t plus a, and this is your sine t. Now what I need to do, that I need to expand this sine a plus b using the formula sine a cos b plus cos a sine b. So what this will become? This will become sine t cos a plus cos t sine a, and everything divided by sine t dt. So now see, I just try to break this down into the two fractions, this upon this plus this upon this. So I'll get sine t cos a over sine t dt plus cos t sine a over sine t dt. Now sine t cancel and the cos is constant. So just write cos a 1 dt plus sine is constant here, so sine is outside, and the cos t over sine t will be cot t dt. Now cos a and integration of 1 dt is t plus sine a. What will be the integration of cos t dt, cot t dt? If you do not know the formulas, here I can derive it for you again using method of substitution. That is cot t over sine t. Cot t is nothing but cos t over sine t, and if you take sine t as theta, then differentiation of this gives you cos t dt equals d theta. So this one becomes d theta over d theta, that is log mod theta plus c, that is log mod sine t, because theta is your sine t, log mod sine theta plus c. This is the formula for the integration of cot t, and which I'll use this formula directly. So this will become sine a log mod sine t plus c. Now I need to put the value of t back into the expression. The t is x minus a, so this becomes x minus a cos a plus sine a log mod, sine a log then mod, sine a log mod sine, at place of t you write x minus a and plus c. So this is your answer. So this is, again I am suggesting in a very simple way, unless you memorize the formulas, in the competitive examination you will not have much time to derive. So why do we practice? We practice only so that we just memorize. The formula should be at the tip of your tongue. Then only this method of suggestions or method of substitutions, which comes directly to us in the form of method of suggestions, like when you see the terms and then the required terms are present in the given expression, then your mind automatically suggests that what should be the proper substitution, and that is When this happens to you, then you can say you have the better control over the method of substitution. Thank you very much. In the next video, we'll take another form, another kind of method of substitution with the different forms.